Good morning. Today we'll discuss about differential protection of busbars. In the last lecture, we have seen the need for busbars, and we have also seen the advantages which are provided by the electric busbar system when compared to conventional wiring system. Also, we have seen the limitations of busbar system. And at the end, we have seen the protection of busbars. Why do we should go with protection of busbars along with the common faults which do happen at the busbars. So in this lecture, we will see how differential protection is applied to the busbars. So I hope that by the end of this lecture, you will be able to describe the differential protection which is applied for the busbars. So I'll start with the basic differential protection relay, and next I'll move on to the operating principle of differential protection and also the types of differential relays, and next we move on to how to apply this differential scheme for the protection of busbars, and followed by the steps which are involved in implementing differential protection for the busbars. So let me start with the basic differential relay. A differential relay is one whose operation depends upon the phase difference of two or more electric quantities, and it works on the principle of comparison between the phase angle and the magnitude of the same electrical quantities. Apart from this, where we can use the differential protection. Differential protection can be applied to generators, transformers, feeders, large motors, and especially busbars. So these differential relays are basically classified. The commonly used one is a current differential relay, and we do have this voltage differential relay, and the improved version, which we call it as bias differential relay or percentage differential relay, and finally the voltage balance differential relay. So in today's class we will see only this current differential relay, which is widely employed for differential protection. A simple straightforward current differential relay. So a simple current differential relay, it senses and operates the phase difference between the current entering the system and also the current leaving the system. Now let us suppose there is a device here. So let us suppose this is the current which is entering, I input, and this is the current entering. This is the current leaving. So it measures the current entering the system, measures the current leaving the system, and thereby if there is any difference between these two, then it operates. It gives signal to the circuit breaker, which means that ideally for any case, if there is no fault, now let us suppose this is point A and this is point B. If there is no fault between A and B, then I input is equal to I output, right? So which means that I input minus I output is equal to 0, or maybe some small value, right? If it is not equal to 0, which means that the current is not going to point B, but it is leaving to somewhere else here, which means that there is a fault which is happening between A and B. So the differential relay always measures the phase difference between the input and output current, and if it is greater than 0 or maybe a pre-specified value, then automatically it will provide a signal to the authority or the circuit breaker. So first of all let me show this is a differential relay. If you carefully see, now let us suppose this is a system or an equipment, let us suppose, which is to be protected. Now this dotted line represents a protected system. Now this is my incoming current I1 and this is my outgoing current I2. Now let us suppose this is incoming and this is my outgoing current. Right. So normally if the system is in this way, normally I1 and I2 direction will be like this, right? Let us suppose if there is a fault outside which is not related to this system, then automatically I1 and I2 direction will be in this way. Now let us suppose if the fault happens in between these two, then automatically what happens? The current will be, see, this is your fault. So automatically the current direction will be changed. Earlier the current was moving in this fashion to this fault. Now what happened? This is one current and this is another current. See, whenever there is an internal fault, then the direction of I2 also is going to change. See, that's why here, so this is I1, I2 is in reverse. This is an external, this is a fault. This is an internal fault, okay? Because of this internal fault, I2 is also moving into this fashion to the ground. So since both the currents now see here, I1 is in this fashion, I2 is also in this fashion. Now, in this one, see, if the fault has occurred outside this dotted line, see, I1 is this, I2 is this one. So what is the difference between I1 minus I2? It will be 0, right? So the current which is flowing in this operating coil was 0 in this case. Since it was 0, no fault has been detected. But whereas in this case, say I1 minus I2 is not equal to 0 because it may be like this. I1 may be equal to minus I2 or I1 minus I2 may not be less than 0. So that's why your circuit breaker gets a signal. Your relay operates and it provides a signal to the circuit breaker. So the same has been represented here. The dotted line shows the section which is to be protected and the current transformer is placed at both ends of the, see, this is to be protected. So I'll place a current transformer here. This is input current and a current transformer here. This is output current. Now the secondaries of these two transformers, they will be connected using the pilot wire scheme. Thereby the current which is inducing in these CTs, then it automatically flows in the same direction. Now the operating coil of the relay, which this is the operating coil of the relay, is connected to the secondary of the CTs. So under normal conditions what happens is the magnitude of the current in the secondary of CTs, it remains the same and the zero current flows through the operating coil. This is what I have shown in the figure. Now if there is any fault, then automatically the magnitude of the current on the CTs may vary, because of which here the current may not be less than or equal to some predetermined value. So that's why your relay starts operating. Now how to apply this scheme to the protection of bus bars? Now for bus bars, even though overcurrent relays are extensively used, differential protection is one of the commonly used protection scheme. As already said, the basic principle involves, now let us suppose this is the bus bar. So this is the incoming, this is the outgoing, right? So both will be measured. But as already said, bus bar will be having too many number of connections. There might be so many incoming lines, so many outgoing lines, right? So in that case, how you will be connecting this one? So a conventional differential scheme, it compares the currents flowing into and out of the protected zone. If the current flowing into the zone is not equal to the current flowing out of the zone, then it indicates that there is a fault within the protected zone. So the same one, if I start applying for my bus bar. Now let us suppose there are two incoming lines. So I will have CTs on either of the lines. 3 outgoing lines are there. So 3. So these will be connected in parallel. Similarly, these will be connected in parallel. And this is the way how you will be correct. Okay, the differential relay operates to trip the circuit breakers and isolate the fault when it experiences a current here which is greater than your predetermined value. Now, what are the key steps which are involved in implementing this differential protection for your bus bars? So, one of that important thing is, as already mentioned, CTs are installed on both sides. These CTs generally they do measure the incoming and outgoing currents. And the CTs are connected to the differential relay that compares the incoming and outgoing currents and detects any differences. So, as already said, shown in the figure, these are the CTs. So, these are connected at every incoming or outgoing connection. And the differential relay is set up with appropriate settings, including the sensitivity setting and the operating time delay. Sometimes you may use it as a backup relay or secondary relay or a primary relay. So depending upon your requirement, you will be setting up the operating time. And the relay is tested to ensure that it operates correctly and accurately detects a fault. This is the pre-setting function where before installment itself you will be checking it. If the fault is detected, then the relay operates to trip the circuit breakers and isolate the faults. And the entire system is regularly maintained and tested to ensure that the differential protection remains functional. So these are the simple steps which you as a fresher should follow. Now, this is the representation as already I told you. See here, there is only one incoming line, two outgoing lines. For one incoming line, I do have a CT. If there are two lines, then automatically I'll be using a parallel connection here. So the resultant, let us suppose this is IA, this is IB, and this is IC. So as long as IA plus IB is equal to IC, then the system remains healthy. Okay. So coming to in precise one, the bus bar protection is basically fed by a generator and it supplies load to two lines. Whereas the secondaries of the CTs in the generator lead, line 1 and 2 are also see. This is incoming, this is a generator. Right? These are the loads L1 and L2. So this is the incoming line, these are the outgoing lines, right? So for this one, the bus bar protection is fed by the generator and supplies load of two lines 1 and 2. The secondaries of all current transformers in the generator lead and also in lines 1 and 2 are all connected in parallel. And the protective relay is connected across this parallel connection, right? So all CTs must be of the same ratio in the scheme, regardless of the capacities of various currents. But we will prove it wrong that it is not going to work out when we do have so many CTs. So under normal operating conditions, or maybe due to external fault conditions, when there are no internal faults, as this bus bar obeys KCL, incoming currents is equal to outgoing currents. So, but if the fault occurs within the protected zone, then the currents entering the bus will not be equal to current exiting the bus. So the difference of these two currents, it will flow through the operating point of the relay and cause the opening of the generator, the circuit breaker, and each of the line circuit breakers. So then that is going to be a big problem. So coming to the conclusion, a quick revision of what we have discussed. Electric bus bar is very important and it is to be protected. The common protection scheme is differential protection, and we have seen different types of differential protection: current differential, voltage differential, percentage differential protections. The commonly used one is current differential protection, where we do employ CTs on every line which is incoming or outgoing, which is connected to the bus bar. Okay. So with this, I'll conclude this session. I hope that now you are able to describe the differential protection and how it is to be implemented for bus bars. In the next class, we will see how to select the CT rating of the CTs which are used for differential protection of bus bars.